Good evening, friends. Welcome to Eastern Academy. Now we are going to discuss about C language as a part of embedded system programming, and it's going to be session 7. So we are going to discuss about pointers. You know that it's a most critical thing to understand in the embedded system. Pointers equal to embedded system programming is equal to pointers. That's it. And this, see, I'm not trying to make you the big one. It's a very simple one. Don't get confused. It's as I say, it's a simple one, not a big concept or anything. And before that, there was somebody has asked a doubt in the last class extension, which I'll explain to you that what is an extension. That is nothing. Suppose I say CHAR equal to ESN. I've told that when you do this in the memory, the compiler allocates A of 0, A of 1, A of 2, A of 3, and A of 4, because 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. This is sorry. 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 0, 1, 1, 0, 1. This is what exactly happening. That's why I'm writing in binary. Then N, 0, 1, 0, 0, 1, 1, 1, 0. Now, this time I put 0, 0, 0. Now I can print like this. I can put print of %d, comma, A of 4. If you do %d, what the printf does, it takes a value 0, 0, 0, 0, 0. It does in 1, 2, 4, 8, 16, 32, 64, 128. Total is how much? 0. So you get on the screen 0. Understand? These are all done by printf. Now, if you put here %c, A of 4, what the printf will do when you put the %c, it goes to the table. What table? Your ASCII table. The ASCII table, if you put, let's say, A of 0, when you put A of 0 is how much? 1, 0, 1, 0, 0, 0, 1, 0, 1. What is that is E. So you get on the screen E. That is fine. But when you put A of 4 is 0. So this guy goes and refer the ASCII table. The problem here is no characters. The ASCII table for 0, no characters. So on the screen, you will get blank. This is called null character. That is ASCII table. So if you put %d, you will get 0. If you put %c, you get nothing. You don't see anything on the screen. Please understand. That's why we have to use %d, not c. C will go and refer the table. For 0, it's a null character. So even other characters, not only 0, you have to go and refer the ASCII, go and search the ASCII table, try to see all the characters. That's a problem. Now, let us do one very important thing now. This already we discussed only, nothing more than that. They say CHAR X. I given a X. The moment the compiler compiles this line, it creates a symbol table. In the symbol table, it's the location. Okay, sorry, symbol and location. So let me write it bigger one because it's symbol. So what's the symbol here? X. The location, the compiler will allocate itself anything. You cannot allocate. You cannot allocate. Please understand, the compiler will allocate this address. You cannot do anything here. So now you put X at 1000. Done. And there's a trick here. This is address. So they put and here to tell you that it's address. Let us say here, if you put and x, so if you put here x is equal to 50 in a memory, what is inside the memory? Content. And this is the location. Location and content, don't get confused. The content is called variable. The location is called pointer. If you don't know both, then it's waste. If you say where to store, and if you don't know what to store, you need both. Where and what. It's a combination. But unfortunately, when you write x is equal to 50, this is actually like this. Okay. You are storing and x and x, both. That is what the meaning. They don't show you this and x because that they take it automatically from the symbol table. That's the problems we have. The problem is you don't see this actually. So you should have the content and you should have the pointer. That's what you're doing. Where? What? But unfortunately, this is, you don't have a control. This is assigned by the compiler. If you say here and x is equal to 3000, x is equal to 10, the compiler will give you errors. You are not permitted to change that. Let us see the code now. Let us as usual, let us do the small code now. One minute. I should have done it before. So we will try to change the address. We try to change the address. I think my monitor is visible to you. Am I right? I've written a very small program. Let me compile it. Let me compile it. It's a very small program, which we all will know that. Then I run it. So you get 10. There's nothing big in it. And it takes about 0.135 seconds. Okay. Now do here. I'd like to see the address. If I put here and x, I just put here and x instead of x. We see here. See, this address is 64 lakh 22,000. That's a location that is saved. Okay, is it clear? Now I say here percentage xd comma x. I print both. I print both now. So this is a location and this is a data, all correct. But now when I do the thing, a small change here, I put and x is equal to some my address. I won't put some somewhere. I don't want to store what he does it. Now when I'm trying to change the location where, see here, see, error, L value required to be operand of assignment. That means that you're doing a mistake, he says. This is not even getting compiled. This is not even getting compiled. So that means that this address and X is called. This is and X is called fixed address. Fixed address, you cannot change it. So understand that this you don't have a permission to change the address. You cannot do that, please. Then how do I change? So Dennis Ritchie has given one small thing here. He said that you can do that, but put a star here. Now, by putting a star here, you are telling the compiler that, hey, star X is a variable. Understand one thing? Now, star X is a variable. Now, X is a pointer. When I put initially X was variable and X was pointer. Fixed. But now, when I put star X, it became variable. Now I can say here, X is equal to 10,000 and star X is equal to 10. Now I'm printing X and star X. Okay. Now I compile it. Okay. That forget about. There's a small warning. Okay. It's a. I have to tell him that, hey, I'm putting the now. This is called typecasting. That means that I'm telling the compiler, I'll tell you the meaning of these two. See, when I don't do this, it was giving error. Am I right? It was giving error. Now when they compile it, it was giving warning. Now I'm not doing anything. I'm just putting whatever the before X here declared, character star. This is called typecasting. We'll discuss later. Don't get confused now. Sure. What mistake I'm doing? See that? Because I want to remove the error. That's why I'm showing this to you. Now you see that no errors. But when I execute the program, see here. See, 10,000 and returned is 0. But this not be always true. I've written now 10,000 and 10,000 returned 10. Am I right? No errors. But if I give here, instead of 10,000, I put 5,000. Now you see here what happens. See here what happened? It is hanging. If you ask me what is the problem in this program, see that? It is returned with negative value. Understood. Now, what is wrong? I put here 1 lakh. See, it's printing. So I'll tell you the mistake here. What's happening? You need to understand the difference between now what is software, what is firmware. That has to be. Your time has come. I'll explain to you now. I'll explain all the three. Everything now. I'll clarify all your doubts here. I just want to show you that. So what happens is this. When I declare thing, there are two ways is possible. One is I declare a variable either x or star y. If we declare x, and x is a location and x is a variable or content. This is English. Same thing we call pointer and variable. We call software. The same thing is called address and data in hardware. All are same. All the three are same. Don't get confused. If we put star x, star x is a content, star x is a variable, and star x is a data. But x is a this one location. So let's put star y, not to confuse you. Location, pointer, and address. Since now we are discussing about only software, I will never use these two, location or content. Also, I will not use address and data. When I'm discussing hardware, I'll discuss call address and data. When I discuss in software, I'll discuss the same thing as a pointer. Okay, understand that. So, what is advantage? If we put char x and x is equal to 1000, this is wrong. Compiler will not allocate because this is a fixed pointer. Who fix it? The compiler. So you don't have permission to change the address. So you cannot store the x wherever you want. If you want to do that, you write here star y. You put y is equal to 10,000. Star y is equal to 10. That's all. At memory, at 10,000, you can write 10. This is permitted. Understood the difference between these two? If you put a star, you have a permission to change the address. Here you don't have a permission to change the address. So here you have to go with this guy. X is equal to 10. Whatever address he allocate on the symbol table. Understood that? Nothing more than that. Don't get confused more than this. Now, I'll give you one more small thing. This is what the trick. Now, when I do put char x, then what happened? For the x, the address is allocated by the compiler, and the x is stored in the memory. Since you put char, he allocates only 1 byte. And this is AND x. That's it. So in memory, you have only 1 byte. But when you do like this, char star y, here star y is allocated in the memory as 1 byte. Then, and we allocate here y, but y is a symbol. So what system does, for y you put and x, and y, and y. This y is a variable. Please understand, there are two ways here. There are two types. Here, the y is a pointer. The same y is a variable. So he allocates a space Y for 32-bit. Because let us assume that your microprocessor is 32-bit microprocessor nowadays. So they allocate 32-bit long. So in your memory, you allocated 5 bytes, not 4 bytes. That is the reason when you say Y is equal, that's the reason here, when you say Y is equal to 1000, it is saved here, 10,000, because Y is a variable. So like here, grandfather, father, son. There were 3 people, but actually there are 4 relations. That is, he is a father and he is a son, one relation. And he is a father, he is a son, another relation. So he acts as a son for his grandfather. He acts as a father for the son. Like that, the Y. Y has 2 meaning. The Y act as a pointer. The Y act as a variable. That means that, I'll tell you now. When it acts as a variable, when it acts as a pointer. When you put here Y is equal to 10,000, that time the Y acts as variable. When you put star Y is equal to 50, that time, this time Y acts as pointer. That's why this is called, star Y is called variable pointer. And X is called fixed pointer. The advantage of this one is you can write anywhere as you wish, but that is not always true in some cases. When, let us take all our computers. The computers, we have a hardware, and above which we have something called operating system. Above which your application or program. What the operating system does, it does not allocate all the memories for you. When you run an application, it allocates some memory location for you. So if you try to use the other memory locations other than this, what is allocated for you, then it will give you error. That means that it goes like this. All the systems are having something called memory management unit. So every address given by the microprocessor goes via the memory management unit. If you put the address Y is equal to 1000, star Y is equal to 50. I showed you the same thing here. I showed you the same problem here. When you try to do the programming of, when you do this here, when you try to store the address 1000, when I try to store 10 there, see, it is hanging. And this timeout and the other is the -1. This should never be in negative. The process should be written always 0. If it's written negative, it means that something is wrong. What is wrong? It is because you don't have a permission to write it there. Who stops you? That MMU. So that's operating system. That's why don't do this. This is absolutely wrong. You cannot you cannot force a pointer in your computer, but same thing works very good. The same thing works very good when you try to run the program on your microprocessor. Let us assume that you run a program, you write a program this, star Y is equal to 50. You compile the program. Then you download the program, you get the binary file. You download it into the ROM. and the microprocessor executes, then this is fine. This is called, that means that you write a program which is going to execute by the microprocessor directly. This is called firmware. Please understand the difference between firmware and software. You write a program, the same program is called software when you run it on OS and this microprocessor. This is called software. The same program, when you give it directly to microprocessor, it is called firmware. Please understand the difference. The same program is called software. The same program is called firmware. There's nothing called firmware or software differently. Both are same. Whatever program you are writing in C, if you execute on the microprocessor directly, that's why they call this as a bare metal. Bare metal. That means that you're running it on silicon directly. Bare metal. But if you run it above OS, then that is called software. So don't get confused between firmware and software. So there are two pointers. One is called fixed pointer. Other one is called variable pointer. You cannot change it. Can't change. Understand? When we program for microcontroller, we know address is normal programming. No, we know the address. There's something called we don't know. When you do the microcontroller programming, there's a microprocessor, there's a ROM and RAM. You know the address. You can write anywhere. There's nothing wrong. You can write anywhere the program. We will see that when you're discussing about embedded system programming. I'll show you that. In a microcontroller, you will never get there. There's nothing called MMU. You will know OS. You are writing directly your program on the ROM. The microprocessor will take, it will work directly. You know the address. In microcontroller, you know the address. You go to the data sheet, they'll give you the address. So you can write anywhere as you wish in microcontroller. So you know the address. You know the exact address in microcontrollers, please. But only in the computers, you cannot write the address wherever you want. For example, in microcontroller, you want to write the address called some 2000. You put char star x, x is equal to 2000, star x is equal to 10. This is perfectly valid in your microcontroller. But this because this is firmware. But this is wrong in software. You are not supposed to force the address. How do I set the address? There are so many methods. First method is like this. I say int a comma star b. Now I say b is equal to and a, because and a is allocated by the compiler. That I can address. This is right. But if I put b is equal to 1000, this is wrong in software. Also, I can do another way. I can do b is equal to, there is a software called malloc. I can request the computer to allocate some 1000 bytes, 100 bytes. That is right. Understand? That is possible. But you cannot do the other way. But these are all difference. So fixed pointer you cannot change. That is and x. X star x, x can be changed because x is a variable pointer. Now, third one is called array pointer. Array pointer. Cannot change. That is, if I say int A of 10. In this case, A is address. A is a pointer, sorry. A is a pointer. A of 0 to A of 9 is a variable. Please understand only the 3 pointers. One is fixed pointer, you cannot change. One is variable pointer, you can change. One is array pointer, you cannot change. You cannot put the array as you wish. You say that A of 10 and A is equal to 1000. This is wrong. Okay, I'll show you now. I'll show you that how system is giving error. We should know that how system is giving error. Sorry. Now I say here x of 10. Okay, now I say x is equal to 1000. I print x of, I put the variable x of 0 is equal to 1. Then I print percentage d x of 0. I initialize, I want to do print it. All right. Okay. So I have done a small program. Now you see that. Now, first let me comment this line. So I compile it. I execute it. I get 1. But when I put the fixed address here, see, assignment expression with array type, that's wrong. You are not supposed to do this. This is you cannot change the address of array, which is fixed by the compiler. You don't have permission. So please understand one important thing here. One important thing here. See here. You can say A of 10. Let's say A of 4, easy. System allocates A of 0, A of 1, A of 2, A of 3. Am I right? Now, this is a variable. These 4 are called variable. But A is called address. That is also called fixed address. Fixed pointer. That's why I say you cannot change. But this is also same, and A of 0. So please understand, and if you put the and here, that become address. So both are same. So A and A of 0 is same. But generally in the industry, we don't do this. We don't put this. We use A because that's the reason the compiler C has given a provision for you to treat A as an address. It's easy to do that. That's why they are given. So see, please don't get confused here. This is what I'm trying to say. If I say CHA or X, X is a variable. If we put CHAR, X of 10, X is a pointer. That is also a fixed pointer. You cannot change. Do you understand the difference between this and this? When I declare as a single variable, then it's called variable. If I declare as an array, that same X become a pointer now. And that is also called fixed pointer. That's why when I say, I previous session, I told you a program. I've written a program, CHAR, A of is equal to welcome. CHAR B of is equal to Surabhi. If we say A is equal to B, what is A? A is a fixed pointer. Array pointer which is fixed, cannot change. If you are trying to change, it's illegal. This is wrong. That's why you got error. You cannot change which cannot be changed. You are trying to change. So do you understand the difference between this? That means no. What is very important thing is this. That is, when you declare CHAR star X equal to 1000, this will give error. If you run the program, it may give any error. Sometimes it will say that segmentation fault. That's the reason most of the software engineer, okay, they always worried about pointer. But for us, for the firmware people, this is very easy. If I tell you that write to the location on the memory at 5000, very simple. You put 5000 star X is equal to 10. This will be done. This is a very, very valid program on firmware. And this is the one we are going to use maximum. This is the one you are going to use maximum. If you understand that all microcontrollers are same, whether it is a 8051 or PIC or ARM or Atmel, all are same. They will give you a data sheet called memory map. The memory map, they will tell you that what memory, what to write. Then you have to write it. So you have to watch the memory map and get the address and write the value that will behave like that. This is going to be the one which is going to be mostly used by embedded system programmers. So don't underestimate that. That means that I can write, let us assume that my microprocessor is 16-bit. Let us assume that my microprocessor is 16-bit. That means that the starting address become 00002 F. Please understand. So I can write a program now. CHAR star X. X is equal to 0x, any address. 5673. Star X is equal to 25. So at location 5673, 25. That means that you can change from 000 to FFF. You can write anywhere as you wish. This is not possible by the software people. That's why people in the college everywhere have told you that pointer is difficult one. Why they say pointer is tough is this is not possible above OS. But this is a very, very easy for embedded system programmers. That means that if I tell you any address, any value you can write. If I tell you that, hey, at location 5123, write 76. Finish. You put here 5123, 76. That's all. You can write anywhere, any value. That is possible only by the firmware people. Because you are writing the program directly on the microprocessor. For example, I'm a 32-bit address. That means that your address is starting from 000, 32-bit to all Fs, 8 Fs. That means that you can address anywhere. You can put here X is equal to 0x56731259. Star X is equal to, let's say I'm 32-bit. Data bus. I can write 1, 2, 3, 4, 5, 6, 7, 8. You can write anything. It's all possible. So you can write anywhere as you like in firmware. That is a major advantage of firmware. which is not possible in software, because your operating system and the thing will not allow you. And this is the most important you have to remember. But remember the other one also. If we put char in whatever it is, x of 10, y of 10, these are called fixed pointers or array pointer. Okay. This is what fairly your idea. But there small things are there. I'll tell you one small thing. See, if we put char x is equal to 10, x plus plus, printf since I increment x here, I'll get here 11 because I integrate 10. If we put here character star x, character star x, x is equal to 1000, because x is address now. In this case, x is a variable. In this case, x is address pointer. Now we say x plus plus, printf I get here 1000, 1001. But if we change the program here, char to int, I change int now. Let's say int is a 32-bit. Assume that long. I change here long int. Now when I do the long int, then what happens? Think. X is equal to 10, x plus plus, it shows 11. But here, long int, x is equal to 1000, x plus plus, you get 1004 because x is a variable, x is a pointer. So one pointer shows 1000. If you increment the pointer, it will point the next location, next variable. That's because it's integer. It occupies 4 bytes, becomes 1004. This is called pointer arithmetic. You understand the difference now? When I put here, if instead of integer, if I put character, char, I will get here 1001. 1 will be incremented because char occupies 1 byte. Here 11. But if I put here long, instead of char, I put long, then the increment get changed here. I get 1004. Here I get 11 because this is normal variable increment, but this is a pointer arithmetic. When you increment the pointer, that will increment based on the size of your declaration. Please get it. If you have any issues, let me know. If you have any issues, let me know here. So don't get too much confusion about pointers. They are very easy. And one more thing, let me tell you one thing. These are the small thing you should know. If I say that char x is equal to 10, printf percentage d comma 10, sorry, x, you will get 10. If you put here char percentage x is equal to 10 and printf star x is a variable. But when I put percentage x, I should give address. But I'm directly storing 10. So what the compiler will do, if you put like this, this is equivalent to this. Please understand the difference. See, if I say that char x is equal to 10, this is equivalent to char x is equal to 10. This is the meaning. But if I write now CHAR star X is equal to 1000. What is the meaning of this? X is equal to 1000, not star X. Now I'm initializing the pointer. Now if you do printf %d star X, since I have not written anywhere on the location 1000, I will get junk. I'll get junk. Please understand that these two differences. If you don't understand these two differences, it's tough for you. See, very unfortunately, what happened when we have learned the C programming, we used the operating system called DOS. I'm talking about 1990s. Those days, we didn't have anything called MMU or anything. So there's nothing called illegal address or anything. But today, you cannot learn this. I cannot show you this in your computer program. I have to show you this is the firmware. So do you understand the difference? If you have any doubt, let me know. What is CHAR X is equal to 10 and char X and the thing? So I'll give you one important thing now that we'll discuss later in a very elaborate way. But I'll give you the idea now, because this may help some of you to write program. If I say now a function main, then I write a program int star X or int X. And they say that I use a small thing called function 1. And I'm passing and X. I say printf. I put X is equal to 20. Printf. Now I have a function called int function 1. This function 1. And I put here int star Y. See here what I put here, because I'm getting the address, I'm putting star Y. So what is the meaning of this is when I call the function int star Y equal to and X. This is what the meaning. This and X goes here, the star X goes here. This is what meaning called parameter passing. That means that the Y becomes and X. If I put here internally, star Y is equal to 50. Now let us see what is happening. Now what happened? Please understand here how it happened. Inside the memory, I have a variable called X. So and X. And I stored 20 here. That is fine. This is called X. This is and X. But inside the function, another memory is allocated called Y is a address and Y and Y. Then I have another thing called Y and star Y. Understand the thing. When I say int star Y, I allocate for Y, I allocate for star Y. The two locations are allocated. Since I say now, when I pass the parameter, the meaning is int star Y is equal to and X. This is going to Y. So and X is here. Let us say 2000. Now for the Y, I store the value of 2000. Now when I say here star Y, the Y become 2000. This is 2000 is here. So I go and say save here 50. I'm changing your variable. Now when you print here, you will get 50. You will get 50, not 20, because you have changed here. So your variable is changed by the function program. You are passing, this is called, you are passing the address. In C++, they call this as a pass by reference. But here in C, we call this, you are passing the pointer. So you are passing a pointer, I change your value there. So this is, even though if you get confused, go and watch this video once again. And if you confused, leave it. I'll explain this later in a more elaborate way. Okay. One of the class, I'll explain this in an elaborate way. Don't get confused. This is when you start writing a program, you'll understand. This is not a very great. You have to understand that this statement. When I do that int star x is equal to 1000. That means that you are not initializing star x, you are initializing only x. Now this is x is equal to 1000. You are initializing only the pointer. You are not initializing the variable. Please understand that. These are all certain C rules. You better behave that. Okay. If you have any doubt here, ask me. I explained to you that 3 pointers, fixed, variable, and array pointer. Okay. So that's enough. Then we have a lot more things called pointer to pointer, double pointer, and array pointer, function pointer, so many things. They're nothing. If you know this, if you understand this, you will understand that. And I've told that how the pointer is initialized. Yeah, typecasting is basically tell the compiler that if I say that, if I tell the compiler, I declared here char star x and x is equal to 1000. The system assumes this as an integer, but this is a x is nothing but a character pointer. So you are doing something, you are doing some mismatching. Both are same. This guy will accept the same value, but the type is different. One is integer, one is character pointer. So what I am doing is I am converting this guy by putting this typecast. By putting the typecast, I am making him to understand that, hey, I know that, man. I know 1000 is integer, but please put it, it's both are same. So then he will not give error. Typecasting you to tell the compiler that I'm not doing a mistake. I understand this. I understand that I am putting the integer on the character. That is to tell the compiler. Otherwise, by mistake, you'll be doing that. It will show some error somewhere. These are all the stringent C conditions you should remember nowadays. When we were doing it, nothing was like this. But nowadays, you need typecast. That means your LHS, left-hand side and right-hand side should be same. Should be same, please. Okay, then. We'll discuss this later on. Right now, since it was giving error, I showed you that. But there's nothing great about in typecasting.